question number 6. Okay, so for this question we'll be proving a trigonometric equation which we are given. So we're given this equation to prove sine of a plus b multiplied by sine of a minus b equal to sine square a minus sine square b. Okay, so to prove this we're gonna start from the left hand side, and right at the back, if I look at the two terms on the left hand side, we can see that there is an identity. If we're familiar with, we can start applying that. So the identity basically goes that if we're given sine of a plus minus b, that is equal to nothing but sine a cos b plus minus cos a sine b. Okay, so basically in case this here is a plus, we get another plus, and then if it's a minus in sign, we get a minus. So if we apply that if we use that and apply it here, what we can get from that is so applying that, we get sine a cos b plus, since the first term is a plus, cos a sine b multiplied by, so the second term now, which is sine a minus b, so this here will be a minus, so sine a cos b minus cos a sine b. So now if we go ahead and multiply the two terms, just expand this. Now if we go ahead and multiply the two terms, we can start multiplying individually first, so it's easier. So this basically becomes, if I take this and multiply it first, what will I get? I'll get my first term as cosine square a cos square b minus sine a cos b cos a sine b. And then for my second term, I'm going to multiply this with this bracket here, and what will I get? I will get plus cos a sine b sine a cos b, and then I will also get minus cos square a sine square b. So if we look at these two terms in the middle here, we can see that they're actually exact same. So this term and the term here, they're the exact same, except they have the terms written down differently, but we know the multiplication is commutative, like we just learned. So we can cancel these two terms together, since one is a negative and the other one's positive. So if we get rid of those two, what we're left with is essentially sine square a cos square b minus cos square a sine square b. Since we know that the final answer which we need to prove is entirely in terms of sines, we need to get rid of this cos squares. So we know a property which we're familiar with is, so we would think that sine square alpha plus cos square alpha is actually equal to 1. So from here we can say cos square alpha is equal to 1 minus sine square alpha. In this example, it actually becomes sine square a 1 minus cos square, will be 1 minus sine square. And for the angle, it's not alpha, it's b in this case, minus, and then we have a cos square a, which according to this formula becomes 1 minus sine square a times sine square b. So if we do this multiplication, what we would get is we would get sine square a minus sine square a sine square b, and then in this side we will get minus sine square b plus sine square a sine square b. So again, if we look at the expressions, we know that these two terms, the sine square a sine square b terms, are the exact same, and hence they would cancel out, and they have the opposite sign, of course. So these two cancel out, and in the end we're just left with the two sines, and we're just left with sine square a minus sine square b, which is equal to right hand side. Therefore, hence proof. So we were required to prove that this is equal to the right hand side, and we just did. So let's see what this solution says. Okay, to prove we will use the angle sum and difference identity. Perfect. Based on that, we expand this, then we multiply all the terms. We're left with this. So when they cancel out, we substitute for cos square. It's correct, and then we cancel out. Perfect. The solution is correct. Okay, next up.